Welcome to Practical Cardiology Pearls, where complex cardiology is simplified. ApoB is among the hottest topics in preventive cardiology right now. But what exactly is it, and how is it different from LDL cholesterol? Let's find out. We have two patients. Both have undergone coronary stent implantation. Both are taking their statin therapy regularly, and both have achieved an LDL cholesterol level below 55 milligrams per deciliter, exactly as recommended by current guidelines. But 5 years later, the patient on the right develops another coronary blockage and requires a new intervention. So how is that possible? If both patients reach their LDL goal, why did one of them still develop progressive atherosclerotic disease? As we know, blood is mostly made up of water. Because fats are not water-soluble, they cannot travel freely through the bloodstream. Instead, they need special transport particles called lipoproteins. These lipoproteins carry fats and cholesterol throughout the body. The major lipoproteins found in the human body are shown here. If we take a closer look at the structure of a lipoprotein, we can see that its core contains fats and cholesterol. These lipids are surrounded by a layer of hydrophilic phospholipids, which allow the particle to travel through the water-based bloodstream. On the surface of these phospholipids are proteins called apolipoproteins. The particles shown here are the major lipoproteins found in the human body. HDL is generally considered a protective, non-atherogenic lipoprotein, and it carries ApoA1 on its surface. In contrast, the other lipoproteins shown here are atherogenic, meaning they can contribute to the development of atherosclerosis. All of these particles carry ApoB on their surface. Let's think of lipoprotein particles as trucks carrying cholesterol. Patient A's truck carries 20 milligrams of cholesterol, while patient B's truck carries only 5 milligrams. So you would expect patient A to have a higher LDL-C level, right? But when we measure LDL-C in the blood, both patients can end up with exactly the same LDL-C value. So, why is LDL-C the same in both patients? The answer is simple. LDL-C does not measure the number of trucks. It measures the total amount of cholesterol being carried by those trucks. In patient A, a small number of trucks carry a large amount of cholesterol. In patient B, a large number of trucks carry a smaller amount of cholesterol. In the end, the total amount of cholesterol being transported is exactly the same. That's why both patients have the same LDL-C level. Both patients can have the same LDL-C level, but the patient with more trucks has more atherogenic particles and potentially a higher cardiovascular risk. So it's not enough to know how much cholesterol is being transported. We also need to know how many trucks are carrying it. Now, let's go back to our two patients. As we've just seen, having the same LDL-C level does not necessarily mean having the same risk of atherosclerosis. Both of our patients may have exactly the same LDL-C level, but if second patient has more trucks on the road, that is, a larger number of LDL particles, then that patient is still carrying a higher atherogenic burden and may remain at higher cardiovascular risk. So the next question is, how can we actually measure the number of trucks, or, in other words, the number of LDL particles? Now, let's go back to this figure. If you look closely, you'll notice that every atherogenic lipoprotein has ApoB on its surface. That means if we measure ApoB in the blood, we're essentially measuring the number of atherogenic lipoprotein particles, or, in our example, the number of trucks carrying cholesterol. These patients are considered to have a higher residual cardiovascular risk. According to the guideline, ApoB measurement should be considered in selected patients to help identify this residual atherosclerotic risk. For these patients, the recommended ApoB target is less than 65 mg per deciliter. ApoB measurement may also be helpful in patients with diabetes and cardiometabolic syndrome. Thanks for watching. Let me know in the comments which cardiology topic you'd like to see next. If you enjoyed this video, please like, subscribe, and share. See you in the next video.